Welcome to Channel Academy. In today's class, we're going to be talking about statistics on group data. Statistics is the branch of mathematics concerned with collecting, organizing, presenting, analyzing, and interpreting data. Take note, the end goal of collecting data is to interpret that data. Now, statistics can help us in various ways. It can help us answer questions in our businesses, even in our everyday life. Let's take an example. Let's say I own a business and I'm selling shoes of different brand, such as Nike, Adidas, and Puma. Now, statistics can help me answer questions such as which of these brands is selling the most. For example, if at the end of the month I sell 120 pairs of Nike and then 85 pairs of Adidas and then Puma I sell 95 pairs. Statistics shows that Nike is the best selling brand, while Adidas is the least selling brand during that month. This information helps my business to make better decision about stocking and marketing product. This and many more reasons is why we study statistics. All right. Key terms used in statistics. So the first one we are going to be talking about is the population. The population is the complete set of items being studied. Now, for example, you're about to purchase a vehicle. Now, all the brands of vehicle like the Toyota, the Nissan, the Hyundai, the MG, the Porsche, every brand is known as the population. You're about to buy a vehicle and you don't know which to buy. You're trying to get the best. For you to be able to get the kind of vehicle you want, you have to check all the vehicles. Now, all the brands of vehicle are known as the population. All right, so let's check the next one. The next we're going to talk about is the sample. Now, the sample is a smaller group selected from a population. Like the example I gave earlier, you're about to purchase a vehicle and you're looking for some special feature of the vehicle. There are various brands of vehicle currently in the market. It's almost impossible for you to go to each of these brands to check. So what you're likely going to do is to pick a fraction of this vehicle, like say 10 of the brands like Toyota, Nissan, MG, Porsche, Lamborghini. Just pick them and then check the feature of each of these vehicles. This is known as a sample, a smaller group selected from the population. The next one we're going to talk about is data. Data are facts, figure, or information collected for analysis. So a data can be obtained from a survey or a research. It can also be obtained from an observation. A survey, research, or an observation that is carried out by a researcher is known as a primary data. So if the researcher is the one who did the survey, researched it, or carried out the observation, that kind of data is called a primary data. But however, if the research was carried out or obtained by an existing source, let's say by an agency, such data is known as a secondary data. So take note, if the researcher was the one who did the research himself, that data is a primary data. But if this data is obtained from an existing source, such data is known as a secondary data. An example of a primary data is when a researcher uses a questionnaire or an interview or an experiment. Now, when a researcher uses a questionnaire, interview, or an experiment to gather data, such data is known as a primary data. Example of the secondary data is newspaper publication, the government reports, also internet source, and then the textbook. Every data you see on the internet was actually gathered by a researcher, and then placed on the internet. Now you getting those data becomes a secondary data. All right, so let's talk about the next one. Observation. Observation is the individual value of the data set. Example given earlier. Suppose you want to get a vehicle. Now you get to the first dealership. You look, okay, what's the price of the vehicle? And you're told that the price of the vehicle is £12,000. So you put your £12,000. You go to the next one. £12,000. Now you go to the next dealership and you're told the next price. The next price is 15,000. You go to the next and they say, let's say £11,000. Now these are all your observation. Every observation you are going to carry out, you're going to put them down. Those are the individual data set that will now aid your decision making. All right, so the next we'd like to talk about is the array. This is the arrangement of raw numerical data in an ascending or descending order of magnitude. So array is the arrangement of raw data in ascending or descending order of magnitude. Let's take, for example, if you have carried out your observation and then you have the data like 5, 15, 20, 7, and 3. Now look at this data. These are the data. Array says that you either arrange this data in ascending order, in other words, 3, 5, 7, 15, 20. So ascending order, so it's going up from the smallest to the biggest. Or you make it descending order. It becomes 20, 15, 7, 5, 3. So this is an array. Both of these arrangements are known as array. All right. Okay, so let's look at the next one. Frequency. Now, a frequency is the number of occurrence of any value in a given data. Suppose you are given a data, say 12. Now, suppose you are given this data. For us to put this in a frequency format, we'll have to first arrange the data in an array and then place the frequency. So let's do that and see. All right, so the first we're going to put down is 12. And then we have 13, 15, 16, 18, and 20. Since the frequency is the number of occurrence, so we are going to count the number of 12 that we have in the data. So this is 1, 2, 3, 4, 5, and 6. So the frequency for 12 is 6. All right, for 13, we are going to count also. We have 1, and that's the only one we have, so it's 1. For 15, if you count, you're going to have 1, 2. So for 15, we have only 2. For 16, if you count, you're going to have 1. So 16 is just 1. And if you count the other, you're going to see that you have just 2 18 and then 2 20. So this is what frequency is talking about. The number of occurrence of a value in a given data. So this is frequency. All right, so at this point, let me quickly talk about tally. So let's just add tally to this point. Tally is the stroke representing frequency. So tally is the stroke representing frequency. How do we represent tally? So now we have 612 in the data. So we are going to count 1, 2, 3, 4. Now when it gets to the fifth one, you stroke the middle, making 5, and then you count one more. This is 6. This is the representation of frequency in tally. So for 13 we just have 1. For 12 we have 2. For 16 we have 1. For 18 we have 2. And for 20 we have 2. So this is the representative. Suppose we have any number that is up to 10. For you to represent 10 in tally format, you just count 1, 2, 3, 4. Once you get to the 5, you stroke the middle and then count another 5. 1, 2, 3, 4, 5. So this is a representation of 10 in tally. So if you put one more, it becomes 11. So this is how tally is being represented. It is the stroke that represents a frequency. All right. Classification of data. Now, data can be classified into two. The first one is the discrete data. Now, the discrete data consists of value that can be counted. Examples of the discrete data are the number of students in a class. So if you say the number of students in a class, the number of students in a class can be counted. Also, the numbers of books in a shelf. Now, these are all examples of a discrete data. You can count them, and give them values. All right, so the second classification of data is the continuous data. The continuous data consists of data that cannot be counted or are unlimited. One thing you must also take note of about the continuous data is that they are obtained by measuring, and also they can include decimal or fractions. So continuous data are data that cannot be counted, they are unlimited. So as such, they are obtained by measuring them. Unlike the discrete data that has whole numbers, the continuous data can have decimal and fractions, measures of central tendency or location. Now, the measures of central tendency are values. They are values that represent the center of a database. So they are values that represents the center of a database, and they include the mean, the median, and the mode. So these three are known as the measures of central tendency, and they represent the center of a data set. Arithmetic mean. Now, the arithmetic mean is also known as the average. It is denoted by x bar. Now, you can read it as x bar. Suppose we are given a set of n numbers. Now, for us to find the arithmetic mean of this n number, we sum all the numbers and then divide by the number n. So the arithmetic mean of this data set is going to be x bar equal x1 plus x2 plus x3 plus xn. Now we are going to divide that by n, which can also be represented as. Now this symbol is known as summation. Let's take an example to explain this. Suppose we are given this set of numbers to find the mean. So what we are going to do, looking for the mean, which is x bar, is going to be the summation of all the numbers over n. All right, so this is now equal to, say, 8 plus 4 plus 5 plus 7 plus 9 plus 3. Now, all over, so let's count how many numbers are there. We have 1, 2, 3, 4, 5, and 6. This is going to be our n. So we are going to have that over 6. If you sum that, it's going to be 36 over 6. Now, if 6 divide 36, we are going to have 6. And this is our mean, which is x bar is equal to 6. Alright, so let's take one more example. So the question says, the mean of these numbers is, don't forget the formula remains x bar equal to the summation of x over the number of observation. Don't forget that, because once you know this, getting the mean is going to be very simple. So which is now going to be, we sum all the observation together and then we divide by the number of observation. So we have 3 plus 2 plus 6 plus 7 plus 3 plus 2 all over the number of observation is 6. So divide by 6, and this is going to be the x bar is then going to be, when we sum the observation, we are going to have 23 over 6, which is going to be equal to 3.83 to 2 decimal place. This is our mean. All right, mean from a frequency table. All right, suppose we are given a data set in a frequency table like this. Let's say we have, and we are asked to find the mean of this data set presented in a frequency table. Now the formula becomes, now take note, fx is the product of the frequency and the value. What that means is that you are going to multiply 2 and 3. So then you can have fx, and this is going to be 6, and this one is going to be 8, this is going to be 6, 5, and this is 2. After getting the fx, which is the product of the frequency and the value, then you sum, which is now going to be 6 plus 8 plus 6 plus 5 plus 2 all over the summation of the frequency. This is the frequency, so you sum the frequency, which is going to be 3 plus 2 plus 1 plus 1 plus 2, and this is going to give us, if you sum everything here, we are going to have 27, and when we sum the frequency, we are going to have 9. So our mean, which is x bar, is going to be 27 over 9, and when we divide that, we are going to have that the mean is equal to 3. So this is our mean. Let's take another example. Suppose we are given a question like this to find the mean. So what we need to do is to quickly write the formula. X bar is equal to the summation of the product of the frequency and the value all over the summation of the frequency. So let's quickly create another. Let's call this side fx, which is the product of the frequency and the value, and this is going to be 4 multiplied by 3 is 12, 5 multiplied by 7 is 35, 2 multiplied by 8 is 16, 7 multiplied by 11 is 77, 13 multiplied by 2 is 26, 8 multiplied by 1, 8. Because we are interested in only the frequency and the product of the frequency and the value, we are just going to sum only those two and ignore the summation of the value. Okay, so the summation of the frequency is going to be 20. So we have 20 as a summation, and when you sum the product of the frequency and the value, we are going to have 174. So therefore, we are now going to have the summation of the fx is 174 all over the summation of the frequency is 20, and when we simplify this by dividing, we are going to have 8.7, and this is our mean. All right. Characteristics of mean. Number 1, it involves all quantities in a data. Now, this is a good representative of data because it's going to use all the data. Number 2, it is the most popular and best understood measure of center. Number 3, it is very sensitive to change, as if one number changes, the value of the mean also changes. Number 4, it always exists and it is unique. Every data has a mean. Even though it's 2, you'll be able to solve the mean. All right. The median. Now, the median is the middle number or the middle value after arranging your data in ascending order or descending order. So when you are given a data set, for you to get the median, you have to arrange the data set in ascending order or descending order, which is also known as an array. Now, take note, if the number of observation is odd, then the median number is the middle number. For example, if you have 2, 5, 6, 7, and 9. Now this number has been arranged in an array, so the median number is this middle number, which is 6. If you're asked to find the median, you just say the median is 6, and that is if the number of observations are odd. But if the numbers of observation are even, what you do, for example, if we have 2, 5, 6, 7, 8, and 9, the number of observation we have here is 6. Therefore, we have 2 middle number. For us to find the median number, the median becomes 6 plus 7 divided by 2, and this is going to give us 13 over 2, which is going to be 6.5, or you can say it is equal to 6 whole number 1 over 2. Still the same thing. All right, the median of the following distribution. So the first thing we need to do is to arrange this in an array. So we are going to do the ascending order. So if we do so, we are going to have now, after we've arranged this in an array, the number of observation is 9, and this is odd. So the middle number is 6. We have 4 numbers at the left and we have 4 numbers at the right. So the middle number, which is this, is 6. So our median is equal to 6. That's our answer. Okay, let's take one more example. We are asked to calculate the median of this data set. So the first thing we need to do is to arrange the data in an array format. So if we do that, we are going to have, if you count the number of observations, that it is 6 and it is an even number. So hence our median is going to be, so we have 6 and 8 as the middle number. So we have 2 observations at the left and 2 observations at the right. So we are going to have 6 plus 8 divided by 2. And this is going to give us 7. So our median is equal to 7. Median from frequency table. If you're asked to find the from a frequency table, there are 2 formulas to solving that. The first one is summation of the frequency plus 1 divided by 2 position. That's the value occupying that position in the frequency. That would be our median if the summation of the frequency is odd. Or if the summation is even, then it is the summation of the frequency divided by 2 position. Now, the value occupying that position is our median. Let's take an example to explain this much better. Okay, so we are asked to find the median age from the frequency table given below. Now, let's extend this table and let's call this total. Okay, so this is the frequency, the number of people is the frequency. So if we sum the number of frequency, which is the number of people, we have 15, and 15 is odd. So it simply means that the summation of f is equal to 15, and this is an odd number. And the formula says for summation of f being odd number, the median is, so now the summation is 15 plus 1, that will be equal to 15 plus 1 over 2. This is 16 over 2, and this is going to give us 8 position. So the value occupying the 8th position is our median. So let's go back up. Now let's start counting from the right. So if we start counting from the right, this is 3 plus 2, that's 5, 6, 7. So the 8th value is in this position. Let's count from the left and also see if that's true. So this is 3 plus 5, that's 8. So our median is equal to 25. All right, so median is equal to age 25. So this is our median. Let's take one more example. We are asked to find the median score from this frequency table. So what we need to do is to sum the frequency. So if you sum the frequency, we are going to have 50. So, and then the formula, which is the median, is equal. So because 50 is an even number, so the median is going to be the summation of frequency divided by 2. The position. All right, so we have 50, so it's going to be 50 divided by 2, and this is going to be the 25th position. So let's go back to the frequency and count from our left and also from our right. So let's count. So this is 3. 3 plus 7 is 10, plus 12, we have 22. 25 is going to be found around the 11th frequency if we count from the right. So let's count from the left and also see. So we have 2 plus 3, that's 5, plus 5, and that's 10, plus 7, 17, plus 11, we are going to have 28. So it means that our median is at the 11th frequency, and the score that is having 11th frequency is 10. So our median is the 10th out of 10. Okay? Characteristics of the median. 1. It does not involve all the quantity in a data, as the median is just concerned about the middle number. Number 2. It is less sensitive than the mean. Unlike the mean that is being affected by any number, the median cannot be affected by the extreme value, and thus it can be said to be the best measure of location or center. 3. It always exists and unique in nature. The mode is the value occurring most frequently. So the mode is the value occurring most frequently, or the value that has the highest occurrence. So suppose we are given a data set like 4, 4, 6, 3, 5. Now, you see that from this data set, 4 is occurring most. So 4 is our mode. So mode is equal to 4. Now let's take another example. Suppose we have 3, 6, 5, 5, 2, 3, 9, 2. Now, if you take your count, if you arrange this in an array format, you're going to have 2, 2, 3, 3, 5, 6, 9. Now, after arranging in an array, you realize that 2 occur twice and also 3 occur twice. In this case, our mode is equal to 2 and 3. And this type of data is called a bimodal data. And if we have a frequency table like this, so the mode is the number with the highest frequency. And now if you look at this data properly, you realize that 12 has the highest frequency. So our mode is equal to 11. Okay? Let's take an example. The question says find the mode of the data set. Now, looking at the data set, you already know that the number that occurs most is 5. So it's simple. So the mode is equal to 5. All right? Characteristics of mode. 1. It does not involve all the quantity in the data. Thus, it is the least representative of data. 2. It is less sensitive as the extreme value do not affect its value, but it provides the least descriptive information about a data. 3. It is meaningful when the quantitative data is given. 4. It is not unique, as it may exist or may not exist. And if it exists, it can be single or multiple. Nature of data by mean, median, and mode. The first one is the symmetric data. Now, in this case, the mean is equal to the median, and it's also equal to the mode. So if the mean is 2, then the median is 2, and the mode will be 2. In this kind of case, it is known as a symmetric or unskewed data. So if you solve for the mean, you have 2, and then you solve for the median, the result is also 2, and then the mode is 2, then the data is asymmetric or unskewed data. Asymmetric or skewed data, the mean is not equal to the median, and it is not equal to the mode. Each of them have their unique value. So if you solve for the mean, you have 2, and then you solve for the median, you have 3, and then possibly for the mode it is 4. Then in this case, it's known as skewed data. Measures of displacement. This is the degree to which data are scattered about its average value. Now, the several measures of dispersion are the range, the mean deviation, the interquartile range, the variance, and the standard deviation. In this section, we are going to talk about each and every one of them, and we are going to start with the range. Range. Now, the range measures the spread of data, and it is the smallest measure of dispersion and is defined as the difference between the large and the smallest number in a set. So the formula for the range is equal to the highest value minus the lowest value. In other words, the biggest value subtracting the smallest value is what we call the range. Let's give an example. Now the range is going to be equal to the biggest value, which is 15, minus the smallest value, which is 4, and that is going to give us 11. So the range is equal to 11. All right. Quartiles. Quartiles are value that divides a set of data into 4 equal parts. Now think of it like this. Let's say this is a line. Now if we need to split this line into 4 equal parts, you will agree with me that the middle is going to be 50%, and this part is going to be 100%, and this is going to be 0%. The middle between 0 and 50% is going to be 25%. And then the middle between 50 and 100 is going to be 75%. So now the 25 is the quartile 1, and the 50 is the quartile 2, and the 75 is the quartile 3. So we can say that quartile 1, the first quartile is equal to 25%, and the second quartile is equal to 50%, and the third quartile is equal to 75%. Now let's take an example to explain this. Suppose we are given a data set. This is a data set we are given, and we are asked to find the first quartile, second quartile, and then the third quartile. Now, the second quartile is the middle number, and if you look at the data set, 10 is the middle number because we have 4 at the left hand and then 4 at the right hand. Our quartile 2 is equal to 10, which is also known as the median. For us to be able to find quartile 1, we'll take the lower half, which is 3, 5, 7, and 8. And then we look for the median. And the median is going to be 5 and 7. So our first quartile is going to be 5 plus 7 divided by 2. And this is going to be 6. Okay? And then for us to be able to find the third quartile, we'll pick, so this side is the first quartile, and this is the third quartile. So for us to be able to get the third quartile also, we pick the numbers at the upper half, which are 12, 14, 16, and 18. And then we look for the median. So this is the median. So the third quartile is going to be 14 plus 16 divided by 2. And this is going to give us 15. So our third quartile is equal to 15. So therefore, our first quartile is equal to 6. The second quartile, which is the median, is equal to 10. And then the third quartile is equal to 15. Alright, let's take one more example. Suppose the data set we were given are... Now take note, you must arrange the number in an array before you can look for the first, second, or third quartile. Okay, so now this number we are given is already arranged in an array. Our second quartile, which is the median, is going to be equal to 8 plus 10 divided by 2, which is going to be 9, which means the median is in between this place. And then we have 4 numbers on our lower half and then 4 numbers on our upper half. So our first quartile will be equal to 4 plus 6 divided by 2. And this will be equal to 5. And then our third quartile will be equal to 12 plus 14. And that will be... And this is going to give us 13. The interquartile range measures the spread of the middle. And the formula is given as interquartile range is equal to the third quartile minus first quartile. Now, suppose our third quartile is equal to 15 and our first quartile is equal to 6, as in our previous example. Therefore, interquartile range will be equal to the third quartile minus the first quartile, which will become, the third quartile is 15 minus, this is the first quartile, so the first quartile is 6. This is going to give us 9. So our interquartile range is equal to 9. The mean deviation is the average of the distance of all data value from the mean. It tells us how far, on average, the data value are from the mean. And it can be defined as mean deviation, MD, equal to the absolute value all over the number of observation. Let's take an example to explain this. Suppose we have a data set of 2, 4, 6, 8, 10. Now, for us to find the mean deviation, first we need to find the mean, which is the x bar. So the mean is going to be the summation of the value all over n. And if you do that, the summation of 2, 4, 6, 8, 10. So the summation is going to be 2, plus 4 plus 6 plus 8 plus 10 all over the total observation is 5. So if you sum them, you're going to have 30 over 5, which is going to give us 6. And that means that our mean is equal to 6. Now let's go back up. For us to look for the mean deviation, this then equal to the absolute value of 2, that's the first observation, minus the mean, 6, plus the absolute value 4 minus the mean, plus the absolute value 6 minus the mean, plus the absolute value 8 minus the mean, plus the absolute value 10 minus the mean, all over the total observation, which is 5. Take note, absolute value means you ignore the negative value. If you simplify the numerator, you're going to have, instead of negative 4 here, it's going to be 4, plus, instead of negative 2, comes 2, plus 0, and this is 2, plus this is 4, all over 5. And now this is going to give us 12 over 5, which is then equal to 2.4. So our mean deviation is equal to 2.4. So this is our mean deviation. All right, let's take one more example. So we are asked to find the mean deviation of this data set. Now, the fastest way and the easiest way I would suggest you answer this kind of question is to first look for the mean and then put everything in a table format. The mean is going to be 3 plus 5 plus 7 plus 9 all over 5, which is equal to, if you sum everything and divide by 5, you're going to have 7. Now that you have 7, so our x bar, which is the mean, is equal to 7. Now we're going to put the data set in a table format. So now let's say this is the value, and this is the mean, and this is going to be x minus x bar. So the first value we have is 3, 5, 7, 9, and 11. So these are the value, and the mean remain the same. So it's 7, 7, 7, 7, 7. All right, so this last table is absolute value, not just the difference. So okay, 3 minus 7 is minus 4, so the absolute value becomes 4. 5 minus 7 is minus 2, the absolute value becomes 2. 7 minus 7 is 0. 9 minus 7 is 2. 11 minus 7 is 4. So the total of the absolute value is 12. So therefore our mean deviation is equal to 12 over 5, which is the same thing as 2.4. So that is how to find the mean deviation. The mean deviation from a frequency table is given as mean deviation equal to the summation of the frequency multiplied by the absolute value of x minus the mean all over the summation of the frequency. We are going to explain this with an example. So suppose you are given this frequency table to find the mean deviation. The easiest and the fastest way to do this is to draw a table. So now let's increase this table like this. Now that you've added 4 more columns, so you start labeling each of them. So the next column is going to be the fx, which is going to be the product of the value and the frequency, and the next is going to be the mean. The next is going to be the absolute value of x minus the mean, and then the last value is going to be the product of the frequency multiplied by the absolute value of x minus the mean. Alright, so with this, it will be easier for you to find the mean deviation. So 2 multiplied by 1 is 2, 4 multiplied by 2 is 8, 3 multiplied by 6 is 18, 8 multiplied by 2 is 16, 10 multiplied by 2 is 20. Alright, so now let's quickly look for the mean. Now, the mean is going to be the summation of fx over summation f. Alright, so if we sum the frequency, which is the f, we are going to have
10. We'll sum the product of the frequency and the value. We are going to have 64. So therefore, the mean, which is the x bar, is going to be, now this is the x bar. So the x bar is going to be 64 over 10, which is going to be 6.4. All right, so come back up to the table. So the mean is 6.4, 6.4. All right, so the next column, we are going to subtract the mean 6.4 from 2. So if you do that, you're going to have negative 4.4. However, we are looking for the absolute value, so therefore we ignore the negative. So it becomes 4.4. 4 minus 6.4 will have 2.4, ignoring the negative. And if you do the same for everything, you're going to have. All right, so now we are looking for the last column, and that will be the product of the frequency and the absolute value. So if you do the product, and that means this multiplying this and this multiplying this, that's how we're going to get the last column. So let's do that. So we are going to have, now we are done with our table. It is now time for us to calculate the mean deviation. And don't forget, the mean deviation is giving us, the mean deviation is equal to the summation of the product of x minus x bar all over the summation of the frequency. So now let's sum the product. So if you sum this side, we are going to have 20.8. Already we know the summation of the frequency, so the mean deviation is going to be equal to 20.8 over 10, and this is going to be equal to 2.08. So our mean deviation is equal to 2.08. So this is how to solve for mean deviation. You just create a table, highlight all the column, solve it out here, sum them, and then it is easier for you to impute in the formula. Thank you. Variance tells us how far the data value are from the average, which is the mean. A smaller variance means that the data value are close to the mean, and a larger variance means that the data value are far from the mean. And the formula can be given as variance V is equal to the summation of x minus the mean square all over the number of observation. So let's take an example to explain this. Suppose we are given a 2, 4, 6, 8, and we are asked to find the variance. Fastest way is to create a table. So alright, so now we have 2, 4, 6, 8, 10. So the mean, let's solve for the mean. The mean is going to be x bar equal 2 plus 4 plus 6 plus 8 and plus 10 all over 5. So the mean is equal to 6. Okay, since the mean is 6, we drop 6, 6, 6, 6. Alright, so 2 minus 6 is minus 4. And then if you take the square of minus 4, you'll be having 16. 4 minus 6 is 2. If you take the square of 2, you'll be having 4. 6 minus 6 is 0. The square of 0 is 0. 8 minus 6 is 2. Take the square of 2, you have 4. 10 minus 6 is 4. Take the square of 4, you have 16. If you sum everything together, you're going to have 40. Therefore, variance V is equal to the summation x minus x bar, which is the mean, square all over the number of observation. Then we're going to have that 40 divided by 5, and the variance is going to be 40 divided by 5, that will be 8. So our variance is 8. Alright, so let me quickly just give us the formula for variance from a frequency distribution is equal to the summation of the frequency divided by. Alright, so this is the formula, and you can follow the same procedure to solve as earlier discussed in mean deviation. The standard deviation tells us the average distance of data value from the mean. A smaller standard deviation means that the values are close to the mean. A large standard deviation means that the values are far from the mean. The standard deviation is just the square root of the variance. So let's say the variance, as earlier discussed, variance is equal to the summation of x minus x bar, which is the mean, square all over n. Now the standard deviation SD is equal to the root of the summation x minus x bar all over 2n. So this can be said to be that the standard deviation is equal to the roots of variance. Let's use the example we used earlier for the variance to explain this. Right. Now, this was the example we took when we were discussing variance. And then we solved for variance and we got our variance to be 8. Now, for us to find the standard deviation of this, all we need to do is a standard deviation d. SD is equal to the root of 8. And the root of 8 is equal to 2.83. So this is our standard deviation. Suppose you are given a data set of the scores of students in a school, and then you calculated the mean. The mean is equal 50 average over 100, and then the standard deviation is equal to 2. Now what this means is that most students score are close to 50, so which means many students had scores closer to 50. But if the mean deviation is like 15, 17, it means that the score are spread far away from 50. Alright, so now we've come to the end of the class. Thank you for watching up to this time. We are going to solve several questions and posts. So if you have not subscribed, please do well to subscribe now so that you get notification when different questions from this topic is being dropped with the explanation. And if you have any question or on anything, you can drop it in the comment section. We'll be in the comment section waiting to hear from you. Thank you and bye for now.